Okay, so today we're going to take a look at an electric pencil sharpener that I actually took apart last year for the Broken Appliance Lab. So, as you can see, we've got a transformer, we've got motor and the stator magnets, we have some gears, but the piece I'm really interested in today is this here. This is a capacitor and it's connected to a series of four diodes arranged in a diamond, and so you can see it a bit more clearly, I've drawn it up on the board. So here we have what is called a full wave rectifier. Basically it's the four diodes, which are represented by the triangle inside the circle, and a capacitor hooked up both to the motor and to the AC power source. So the way that the full wave rectifier works is that basically the current can only flow one way through the diodes. Now, the reason that the current can only go one way through a diode is because these diodes are actually semiconductors made of two layers. One's a P-type semiconductor, one's an N-type semiconductor. And without going too far into the specifics of how they're made, basically they are silicon sheets, which they're not conductors, they're not insulators, they're somewhere in the middle. So they can only conduct a current when a voltage is applied to them. Now, what the P-type and N-type semiconductors do is that some of the silicon sheets are doped with gallium, which means that gallium atoms have taken the place of some of the silicon atoms. And gallium is electron deficient, so it's basically short an electron. And some of the sheets are doped with arsenic, which has an extra electron. And it's these extra electrons in the holes, the extra electrons from the arsenic, and the holes from the gallium that allow electrons to flow, but they can only flow one way because of the way the diode is designed. So taking another look back at the rectifier, you can see that the four diodes are essentially black cylinders with gray bands, and those gray bands indicate which direction the current will flow through the diode. So the current will flow from the end that is solid black color to the end with a gray band. So in this case, the case of this diode, the current would flow from here to here. So, and this is true for all four diodes. So the current would be coming in from one lead, flowing up to the motor here, going through the brushes, through the DC motor, coming back out through the other brush, and would come out at the bottom and would go back to the other lead, which has fallen off. And again, as I mentioned before, some of the current and charge goes to charging this capacitor. It goes to charging this capacitor. And essentially that's just a real-world application of the full wave rectifiers. So looking back at the schematic, we can see that when the current is coming from this lead, it's going to the rectifier, and it can't flow this way through this diode because of the way that the diodes are made. So it has to flow through this one. So it goes up to here, and again, it can't flow through this diode, so some of the current and voltage goes to charging the capacitor, while the rest goes to the motor, and this is a standard DC motor. So the current comes back from the motor and goes through the opposite diode, and it goes back to the power source. Now when the current flips, the current can go through here to the rectifier, goes through this diode, again goes to charging, some of it goes to charging the capacitor, the rest goes to the motor, and you notice that the current's running the same way through the motor no matter which way you go. This is why these rectifiers are so useful. You can use this full wave rectifier to run a DC motor from an AC power source. Now, the reason that we use the capacitor is because when you're running, if you were to use a rectifier without the capacitor, you would get a voltage that looks kind of like this going through the motor. Because when the voltage is increasing, it would start increasing. Then as it goes to zero, it would go to zero. Now, the way the rectifier works means that the voltage always has to be in the same direction, so it would increase again and go back to zero, increase again and go back to zero. And what we have here is what is called a sawtooth voltage, because it's going up and down, up and down. And this isn't very good for a motor because it's not a steady power source. So what the capacitor does is that it smooths out that voltage. So the red line represents the voltage in the circuit when there's a capacitor, because some of the voltage goes to charging the capacitor, and when the voltage being provided by the power source drops below the voltage stored in the capacitor starts discharging through the motor, and it keeps the voltage from dropping too low. And this essentially is how you can use a DC motor. You can use an AC power source to run a DC motor. You can use this full wave rectifier attached to a capacitor.